In this video, we'll discuss these two questions at these timestamps. Near the end of the video, we'll go through one final quick bonus question, which you won't want to miss. It's Rami here. Let's get into it. Looking at this question, in order to factorize, the first step is to try to look for any visible common factors. And since there aren't any, we'll skip this step. Just a quick side point, in the last video, we talked about factorizing quadratics, where we were dealing with all positive numbers or coefficients. So if you're having trouble with factorizing those, you might want to check that one first. Link in the description below. Coming back to the question, the second step is to notice that because we have a quadratic written in the form ax squared plus bx plus c, where a is 1, we're going to factorize this in terms of two brackets and place x at the start of each of the brackets. Next, we need to decide on the constants that are paired with those letters of x. In order to do so, this comes on to the important third step, which is that we need to consider a pair of whole numbers that multiplies to give us the value of c, which is minus 7, and adds to give us the value of b, which is 6. Let's initially think about pairs that multiply to give us minus 7 first, then from those pairs, we'll think of which ones add to give 6. Since we need two numbers that multiply to give us a negative number, this means that one of the numbers must be negative and the other one must be positive. So the combinations of numbers are just 1 and minus 7, as well as minus 1 and 7. And notice that if we were to add the numbers in the first pair, they add to give us minus 6, so we'll ignore that. Looking at the other combination, upon adding minus 1 and 7, we do get 6, so that's the pair that we need. All we need to do now is place those individual numbers in each bracket, and the order here doesn't matter whether you place the minus 1 or positive 7 in the first bracket, and that's the question complete. You can easily check whether this works by expanding the brackets. When multiplying the first terms, we get x squared. Multiplying the outer terms, we get 7x. Multiplying the inner terms, we get minus 1x. Multiplying the last terms, we get minus 7. Now when simplifying the expression, we get left with x squared plus 6x minus 7, which matches the original expression. In the next section, we'll try another example, but we'll swap which coefficients are negative. Looking at this question, in order to factorize, the first step is to try to look for any visible common factors. And since there aren't any, we'll skip this step. The second step is to notice that because we have a quadratic written in the form ax squared plus bx plus c, where a is 1, we're going to factorize this in terms of two brackets and place x at the start of each of the brackets. And next, we need to decide on the constants that are paired with those letters of x. In order to do so, the third step is to consider a pair of whole numbers that multiplies to give us the value of c, which is 24, and adds to give us the value of b, which is minus 14. Let's initially think about pairs that multiply to give 24, then from those pairs, we'll think of which ones add to give minus 14. And those combinations will be 1 and 24, 2 and 12, 3 and 8, and finally 4 and 6. Now notice that if we were to add any of those pairs of numbers together, they all end up being positive, but they're supposed to add to give minus 14, so it can't be any of these pairs. However, as you're probably aware, although two positive numbers multiply to give us a positive number, we also have two negative numbers that can multiply to give a positive number, so it must be two negative numbers for our pair. So I can now add an additional 4 combinations here. Let's just work through the remaining pairs until we find out which one we want. Looking at minus 1 and minus 24, although they multiply to give 24, they don't add to give us minus 14, so we'll rule that one out. Looking at minus 2 and minus 12, they do add to give minus 14, so that's the pair we need. We'll now just discard the remaining pairs. All we need to do now is place those individual numbers from that pair in each bracket, and the order doesn't matter here whether you place the minus 2 or minus 12 in the first bracket, so that's the question complete. Like last time, you can expand the brackets to double check whether you get the same expression as the original. In the next section, we'll move on to our final quick bonus question. With our final question, notice that this time when comparing to the form ax squared plus bx plus c, the value of a is not 1, but it's negative. Specifically, it's minus 1. So what should we do this time? Here's a tip. Whenever you're factorizing quadratics and the coefficient of x squared is negative, take out minus 1 as a factor, then factorize what remains inside the brackets like you normally would. So when we take out a factor of minus 1 for the entire expression, Inside the brackets, we get left with x squared minus 14x plus 24. Then we can factorize the quadratic expression using previous methods that we learned earlier. This expression is actually exactly the same as the previous section in the video. So to save some of your time here, I'll just go factorize that part right away. So that's the question complete. So that's going to do it. In the next video, we'll be factorizing quadratics where the coefficient of x squared is not 1, so you definitely won't want to miss that one. And don't forget to subscribe for more free content just like this, and turn on all notifications so you don't miss any uploads from this channel. If you have any questions, just pop them in the comment section below. Thanks for watching, and I'll catch you in the next video.